Our team, JMVZ Engineering, partnered with Loudon Utilities and Barge Design Solutions to increase the solids handling capacity and decrease the waste output at Loudon Utilities wastewater treatment plant. We will now discuss the technical aspects addressed during our design process.
For the alternative analysis, 3 dewatering systems, a belt press, screw press, and centrifuge, were compared using a multi-criteria decision matrix. This matrix, validated by our mentor Barge Design, evaluated 7 categories, including design redundancy, client preference, volume reduction from the dewatering system, volume reduction with a dryer, operation and maintenance costs, equipment costs, and feasibility. Each category was scored from 1 to 3, with 3 being the highest. A Conley-Sanderson paddle dryer was chosen for its ability to meet the EPA 503 pathogen time temperature requirement. After the evaluation, the belt press emerged as a top choice, aligning with Loudon Utilities' specific needs and constraints. One challenging aspect of the design was understanding how the solids handling equipment worked individually and how each dewatering alternative would impact the system as a whole.
Hydraulic analyses at Loudon Wastewater Treatment Plant aim to predict future flow rates and select appropriate pumping equipment for the solids handling process. Using historical data and a projected population growth rate, we determined a design flow rate of 200 gallons per minute, accounting for future needs. This guided the selection of a sludge pump, adhering to TDEC guidelines and ensuring it meets static and suction head requirements. Additionally, we calculated the optimal polymer dosage for the belt press, considering the projected solids flow rate and polymer speed. This comprehensive analysis ensures that Loudon Wastewater Treatment Plant is equipped for future demands.
Structural services were provided to design a concrete pad for the dryer, a concrete sump pit for the belt press, pipe support for the proposed piping, and a steel mezzanine to access the belt press. The concrete pad and the concrete sump pit were designed in accordance with ACI 31819. The pipe support was designed in accordance with AISC manual. The steel mezzanine was selected from a manufacturer and verified using the AISC manual. One positive outcome I received from this project personally was getting to apply the knowledge I had learned in my structures courses to a real-world application.
Construction management services included developing a construction schedule in accordance with the critical path method, estimating probable construction costs, and estimating annual operating costs. The probable construction cost was estimated to be $5.171 million by generating a quantity takeoff and assembling unit prices. Projected solids production volume was calculated and included with estimations for the proposed equipment maintenance and operation costs to determine an estimate of annual operating costs. A personal positive outcome was realizing the importance of communication within teams and projects, along with learning how to apply technical skills in the real world problems.
The CE400 course has allowed each team member to encounter various experiences that have allowed us to grow professionally and technically. The experiences allowed us to bridge the gap between theoretical practices and the real-world applications. The course has allowed us to learn communication and the importance of communication in engineering projects.